currently checking out this model, the RAP model, the RIP model. Look at this right here. Just look at this here. And this looks like it's going to be a really major storm here, guys. Look at that. That's 2820. As soon as that thing gets here, things are really going to start cranking along the coast. Basically, what's going to happen, you're going to have a secondary storm here forming along the coast, and that's going to cause a major, major storm. Look at this here. Boom, you see that right there? I mean, let's look at the gem here, the Canadian. And look at that, it's dipping well to the southwest. Now the RAP is showing this, the NAM is showing this, the gem is showing this, so this looks more and more like we're probably going to get a good bona fide snowstorm. Especially not for New York City. New York City's going to get some snow, but most of the snow is going to be in a corridor between central and eastern New York, all the way through northwestern Massachusetts, going up to southern New Hampshire and southern Vermont. Going to get really badly hit by the storm. Look at that. Some areas could get upwards of 3 feet of snow. Going to Kuhera, which is the most accurate snow method. So the Kuhera method, which is based on the 10,000 foot freezing level, or temperatures at 10,000 feet. Look at that right here. 4 feet of snow. And this model doesn't even have the precipitation ending yet. It's still snowing. So yeah, look at that. At this point, you're probably going to start changing over to snow because of dynamic cooling. These models have some issues with factoring in dynamic cooling. See, usually dynamic cooling happens when you have cold air being brought down from the higher levels to the lower levels, evaporational cooling, and cooling caused by a storm deepening. So first of all, you're having a deepening storm. So you're not having dynamic cooling here, which would really enhance the snowfall rates. This happened during Winter Storm Athena, so there's a chance now New York City could get a lot of snow. I mean, I wasn't thinking that earlier, but now, yeah, this happens. Yeah, this is going to be a major storm. I mean, look at that. I mean, look how far down south this is dipping. You're going to have a storm that's really just going to blow up and just. I mean, this is only one model, but I'm going to only one model, so let's look at that again. Oops, wrong one. Let's look at that. This is hour 39. Let's see here. So basically, around Ohio, West Virginia, but then it takes it off the mid, like Delmarva area. While the RAP has it going well south here, like, and let's look here. And the way it looks like it really wants to crank up. And this is really going to enhance the precipitation along the coast. So right now it doesn't look like much, but you see that right there? you're going to have a big blow up of precipitation. Just as the storm starts cranking up, you're going to have a big blow up of precip. So snow, rain, you name it. So 3 feet of snow, definitely not out of the question. Looking at surface temperatures, the RAP doesn't do so well handling temps, but the HRRR is better with that. But seeing this here, definitely looks like it's going to be a big storm. I mean, it's going to swing like this, and that's when you're going to get all your heavy snow. So as the low deepens up, as this upper level deepens, and the low gets stronger, you're going to have, first of all, you're going to have precip forming because of cold air loft. You're going to have convection, and you're going to have a lot of precip basically just being funneled just north like crazy. So let's look at the gem again. This is hour 39, by the way. So it was showing light precip. So basically light precip, same scenario, but then boom. Remember that? Just boom right there. And a lot of these models are not factoring in dynamic cooling. Like, this should be snow. This should be snow here because you're having the 32-degree line very close here. So you're going to have a lot of dynamic cooling. And I would not be surprised if this actually happens. And the New York City area, Long Island, could also get at least a foot of snow if that happens. So, I mean, this area is definitely going to get jackpot. Like 3 feet of snow. Boston should get a foot and a half. I mean, earlier I was thinking this storm's going to be a total bust, but now that it's getting closer and in the upper level lows, they're forecasting for the upper level low to do what it's doing now. Major storm is definitely in the works. Yeah. I mean, this is only looking 6 hours earlier. I mean, look at this. Look where. This is hour 33 now. Look at that. Completely like different track and everything. This is looking at 10,000 feet. Very cold air loft. So this is showing, let's go again here. Gem hour 39. You see 2820 here, 2820. The same thing, basically. Oh, sorry. I did the wrong model. But you see this right here, 2820. See how small that is? It only gets fortified after it passes over New York. So what I'm seeing here is I'm seeing a much stronger system here at 850. Let's look at 850 now. The 1290 looks pretty wide. Look at that. Look at that. So right now I'm up to about hour, I think 42 maybe. Or yeah, 39. So it's yeah, it definitely looks like a good bona fide storm is going to occur. See, you have a 994 millibar low here. Let's go to Mid-Atlantic again. I'm just going to show you that one more time. So this is going to come in as a wintry mix. Hour 20, so in only 20 hours it's going to start, precipitating. It's going to go down to 20s tonight in the city, upper 20s. So right when it starts, it's going to start off, according to this run, as rain. Maybe it was a little snow, but according to this run, but unlikely. It's probably going to be mostly rain to start off. And then you see this right here. See how now it's starting to come in from the southwest? This is where you're going to get some very heavy precip because it's upper level low. I mean, this definitely looks like it's going to be a major, major storm. So what I can say is prepare for a major storm. This upper level low is going to make all the difference between. This upper level low is going to make all the difference between a couple inches of snow, nothing, and all out storm. I mean, look at that. It also depends on how deep it gets. If it really gets deep, then that coastal storm could get really, really strong. So yeah, see. So you see, there's one low here, and there's gonna be the secondary low forming right here. And where it forms makes all the difference between rain and snow. Like if it forms further to the south and it's stronger, then you're gonna get a lot of snow in New York. If it forms further north, stronger, you get mostly rain in the city and some snow in the backside. But you see how it wraps up here? That's what's going to give Boston most of its heavy snow, according to this run of the NAM. So the Canadian also has a pretty heavy storm. The RDPS, because most of the heavy snow will probably be, or on this run will be past hour 60. So you're gonna have the first batch of the storm and then the second. So basically, you're gonna have a double hit. You're gonna have it's gonna be a very prolonged storm for Massachusetts, like several feet of snow. I'm not even kidding. This is gonna be a major, major storm. Alright, so there we go, fix that. Fix the title there. So this is Winter Storm Ezekiel here. Let's go back a couple days back. This is how Winter Storm Ezekiel came in. There it goes. There's that upper level system. Very cold air aloft. I mean, this is incredibly cold. So this. So you see here, this is where we are right now, basically. Well, actually, it's about. This is where we are. So let's go here. See, almost in the same position it was forecast to be. I mean, this is a forecast 36 hours out, and this is where we are right now. So you see, hour 0. Forecast in actuality, a little bit further south. But it's a little further south that will make it go further south. So it's like this forecast is not very conducive for snow. So anyway, this is a really complex system to forecast, because if this upper level low wobbles just a little bit further to the south or to the north, make a huge difference. Also, its strength. Я не могу сейчас говорить. Да, я сейчас занят. Я тебе попозже позвоню. So, the upper level low right now this is where it is right now. It's right over the Nebraska-South Dakota border, and it's currently traversing, westward, wobbling a little bit, and there's a bit of a Fujiwara effect going on between these two low pressure systems. Basically, these two upper level lows are kind of dancing around one another. Look at this one, and there's one over here too. See, there's two upper level systems here too. So there's several of them here. It looks a bit of a cutoff flow there. So huge change in the forecast. I mean, the GFS is handling the upper level low pretty well, I have to say. It's handling pretty well. However, it's not handling the surface temperatures very well. GFS always has had a problem with handling surface temps, dynamic cooling, all that. So also it's having the surface low going a little further, too far to the north. So basically, it handled the precipitation pretty well now. But it doesn't usually handle precip very well. So let's go back to here. There we go. And this is my YouTube channel, Storm Fan Lover here. No, I'm gonna mute that. So. Oh. I'm gonna have to shrink this. Yeah, let me just try to frame this the right way so it could. Alright, so I fixed that. I'm just gonna stop streaming for just a second. There we go. Okay, there we go. And let's look now at the, where was I again? Yeah, let's look at the wrap, the wrap. So basically, this model is showing a perfect scenario for a major storm. So now, let's look at the, there we go, here's the upper level low. So this is showing a perfect setup for just an explosive, explosive development. There we go. And so the gem is showing, basically that. Yeah, this is showing just a perfect setup for a perfect storm. Fortunately, there's tornadoes here today, so yeah, we have that to contend with. In fact, there's several tornado warnings right now that I need to talk about. I was so fixated on the winter weather, I didn't even know that there's several tornado warnings in effect. And of all places, there's actually one in Iowa right now where it's pretty cold. Yeah, it's actually chilly where these tornadoes are occurring. There's one near Perry. Radar indicated rotation, so there's no confirmed tornado yet, thankfully, but there's definitely a rotation of this storm. It's near Dawson, Iowa. Temperatures in that area are northwest of Des Moines, just west-northwest of Des Moines. Temperatures there are in the low 50s right now. It's very, you don't usually see severe weather, those kind of temps, but, it's still, there's still instability, there's still severe weather, and some of that, and that energy will transfer to this coastal low, but that upper level low is definitely causing these severe weather. I mean, look at this. As that upper level low moves in, it's going to make the air very unstable. And looking at the radar in Iowa on my phone, there's definitely some thunderstorms moving in. And that's actually the type of storm that they're getting right now. Let's look at convective precip. Actually, let's go to NAM and look at convective. They're actually in here right now. So they're in the warm sector of the low pressure system. They're actually in the cold sector. That's the thing. They're actually in the cold sector. They're behind the 32-degree line. That's the thing. So there might not only is there a rotation, there actually may be some grapple, maybe even some small hail coming down on some of those storms. That's how unstable the air is, because they're actually in an area that favors snow. But because they are getting thunderstorms, with such cold temperatures aloft, it's basically where they are right now. They're in the 50s, and surface temperatures. This is what they're getting right now. This is where all those storms are occurring. A little warm notch right there. But yeah, at 700 millibars, look at there. Boom! Look how cold it is. -10, -11. That's like snow territory. That's only 10,000 feet up. At 10,000 feet, it's freezing up there. So that's just crazy. That's just mind-boggling how cold it is up there right now. At 5,000 feet, which is 850 millibar, temperatures are at freezing. So, from what I hear, I don't know if there's any hail with those, like large hail, but there definitely will be some hail because very cold air loft. And this run already came in about 3 hours ago, so yeah. Talk about one crazy storm. Tornado warning when they're going to be having snow in just a couple hours. It's just incredible. Technically, the air is already cold enough for snow, just a couple thousand feet up. So yeah, this actually might happen. Even though the 18Z runs are not usually very reliable, the fact that it's more than one run that's showing this, it's the NAM, it's the Canadian, it's the RAP that is trying to hint on this. It's more than one model. This is what I'm trying. I was saying that usually high resolution runs are better. I usually would trust the high resolutions over the Euro. Like the Euro has definitely screwed up on the snowstorms before, while the high resolutions have done really well. Euro is a high resolution model too, but the thing is, Euro does better 2 to 3 days out, while the high resolution models like the NAM, the RDPS, the stress plumes usually do better 24 to 36 hours out, as all the ingredients are coming together. For the upper level low, the ingredients are actually up here. So you see here, it's going to briefly cut off, and then this little piece right here, see this little piece here, it's going to merge with the upper level low and force it to go south instead of going west. Can't go west because this is not letting it, so it's going to have to go southwest, or southeast, I mean, and go off the coast. And if it really wraps itself up, then you're going to have a lot of forcing, a lot of lifting, and that will cause a lot of precipitation to fall on the northwest side of this upper level low. Because the upper level low also is a mid-level low, because as you can see, it's very cold air extending down towards 7,000 feet. And even down towards around 850 millibars, there's some of it left over. So basically, if the storm really cranks up, there's going to be a lot of dynamic cooling, a lot. And that could really enhance the snowfall rates. So I'm going to go back to the Mid-Atlantic. I'm looking at the gem again. So look, the upper level low has passed. Let's do a sounding here. Yeah, this doesn't do soundings. Okay. You see this heavy precip here. Heavy precip. But the thing is, look. As you have a lot of forcing and lifting, at this point, you're already going to be snowing in New York. Ignore that it's raining, because the thing is, here's a 32-degree line. Heavy precip, a lot of dynamic cooling, which will cause everything to just change over to snow very quickly. At this point, the rain-snow line will probably be all the way up to eastern Long Island, maybe, if this is correct. And the snowfall rates, like the snowfall in New York City, might be up to a foot instead of 7 inches. So these models are having a hard time handling dynamic cooling, which is a combination of evaporational cooling and cold air being dragged down from higher elevations by heavy precip. Well, I have to go right now, so I'll make another video later. Thank you all for watching and have a great day.